Guys, welcome back to my channel. Today I show you how I created this small program to calculate in a fast way our gradient, divergence, curl, and Laplacian. This is used for vector field operations. These are just operators so we can use later to build the Stokes theorem, the divergence theorem, and sometimes the Green's theorem, but it's a different thing. But for now the operators are here. So I built this program calling my variables right here, and then in my first variable and my variable d, it contains the vector field that contains also the derivatives of every expression in the axis. So as you can see, a, b, c, they are in the spot of the x-axis, y-axis, and z-axis. And then my variable e contains just vector field as a vector. F is the dot product. As you can see in the screen, I'm showing you that really quick. The divergent means the dot product of the gradient with the vector field, and the curl is the gradient and cross product with the vector field as well. And the Laplacian is just double derivative. The second derivative of the expression is like to take the derivative of the gradient of the derivative of the gradient. So that's basically it. So you can see in the screen. Well, so let's run the program. So Control R, and I was just practicing with this problem. It's pretty basic. Here in the screen I'm showing you some problems I'm using. One thing to explain is that this program is gonna help you calculate everything faster. So if you want, you can use the dot product and the cross product in the normal procedures, but I think this program is pretty helpful. So alright, so let's actually solve the problem number 9. As you can see, they're asking for the vector v. It contains r. R is acting as a vector field and equals to r to the minus 2 times r as a vector field as well. So okay, so I'll show you the process for this problem. So here's what I did. I addressed this problem just saying that the r is vector field, right? So it's actually vector field. So I'm writing the little arrow because in the problem is bold. So right now is actually a vector field. So that means r normal without the arrow is right. So it's basically representing the distance. So we want to find what's the distance between 3 points. We normalize the vector field, so that's basically what is r. Then we build the function. So the function, it is the normalized function to the -2, and then times the vector field. So that would be just like this, right? So yeah, because if it's elevated to -2, it goes down and it is squared, but it has a root, so they cancel, and we have x over x squared plus y squared plus z squared. So that's vector field we want. That's a function. So then okay, so if you try to find the curl and the divergence right here, you're gonna take a long time doing this by the traditional way. So you can use a program to enter these numbers as you are seeing in the screen. I entered the data and I got the gradient, the divergence, the curl, and the Laplacian for this. You can see it's very well explained. You can other variables or something, but I don't know, there's different methods to do it by traditional way. But if you want to use a program, it's fine. And you have if you get numbers in some problems like this Laplacian, I get these weird numbers 0.3333 or -6 times the whole expression. You can simple select the vector field and select it, and you can copy it down, and then at the beginning just write expand. I think it is expand. Yeah, it is expand. So you expand this expression and you're gonna have the expression in terms of x squared plus y squared plus z squared. So that's it. You have the well, I don't have the answer here, but you have the answer in the calculator, so that's pretty helpful. So okay, that's it for today. So I love that this is gonna help you out, and alright, see you guys in the next video. Bye bye.